Shri Gurubhyo Namaha, children. Yesterday we were discussing about meter bridge, which is one of the application of Wheatstone's network, and I was also telling you about the practical how it is a practical experiment. I was explaining you the procedure. Hope you went through all the concepts clearly. Hope you are very clear about meter bridge now. Okay, so it is made up of manganese wire or constant wire, and you have copper strips, and you have two gaps G1 and G2. To one gap you connect a known resistance, to the other gap you connect the unknown resistance, and the primary circuit of the meter bridge is with a Leclanche cell and a key, and with all the connections checked, you move the jockey over the wire. The jockey will slide over the wire at a particular point on the meter bridge wire. There is no current, where the galvanometer indicates a zero deflection. So that is the at that point all the resistors P, Q, RS will have the same value of resistance, and there is no current in the galvanometer, and the potential across that is measured. So this is with respect to meter bridge. Today we are going to continue with potentiometer. So what is a potentiometer? Look at your book. The diagram is in page number 113, children. Actually, I'll be able to show you when you come to the lab the picture, how the potentiometer looks like. Okay, but to start with, let me tell you what are the main what is the main use of the potentiometer. Actually, this potentiometer, it is used to measure the potential difference or voltage, current and resistances. So the main use of potentiometer is to measure the potential difference. Now how it looks like? Okay, again it consists of 10 meters of wire made up of again manganese or constant. Okay, we will not use a copper wire, we will go for a manganese wire or a constant wire. In meter bridge, the length of the wire was found to be 1 meter, but here it is 10 meters, and you have so many segments of wire. Now in your this picture we have shown only one segment of the wire. This is 1 meter, but you have 10 segments of wires like this. It looks like a board with so many wires. Each wire has a length of 1 meter. So you have 10 segments, and all these wires are connected with copper strips. Okay, so it is a long 10-meter long wire. It is made up of manganese or constant, and they are arranged in 10 segments on a wooden board. Okay, and the two free ends are brought to the same side, and they are connected to copper strips. All the wires are interconnected. In the board you will be able to see the wires are interconnected on the sideways by copper strips, and the free ends are connected to the same side. So to the left side you have terminal A, terminal B. So the starting wire and the ending wire are connected to the same side, and all the segments are connected in with copper strips. This is how the board looks like. Okay, and you have a meter scale to measure the length, that is balancing length, and all the other connections are here. Suppose let us consider this to be one segment of the wire whose length is 1 meter. So this is connected to the positive terminal of a battery, key and D, and here the positive. Now this is the cell whose internal resistance or potential difference. Now potentiometer can also be used to find out internal resistance of an unknown cell. Okay, so here the cell, this part is to determine the potential difference. So the cell whose potential difference has to be measured is connected to the C, that is the C end is connected to the positive terminal of the cell, and the negative terminal of the cell is connected to galvanometer, that is connected to high resistance, and that is connected to jockey. So this is the secondary circuit, children. This forms the secondary circuit of the potentiometer, and this forms the primary circuit of the potentiometer. Is it clear? So they are connected, and again you move the jockey. So how it works? Now after connecting, you have to check for the connections. You keep the jockey to one side, the galvanometer needle moves to the left side, then move the jockey to the other side, the galvanometer will move to the other side. So if the deflections are there in the opposite side, then the connections are made. So as far as meter bridge and potentiometer are concerned, you cannot start the experiment unless and until your connections are correct. You need to check for the connections. Now that checking can be done as how I said. So you have to check for opposite side deflections in the galvanometer, then you can proceed with the experiment. Is it clear, ma? Now what we are going to do is, you have to move the jockey on the potentiometer wire. So if you keep on moving, so let us start from here. Okay, now when you keep on moving now this wire has already got a resistance. Now let that resistance be taken as R, small r. Okay, as I told you for meter bridge, it is the same, R into L we are going to measure, that is resistance per unit length. Now there will be a current flow in the circuit due to the battery that is connected. So from this point when you start, if you keep on moving the jockey over this wire, now the current will be increasing. Yes, now at a particular point the current will be 0. Okay, the galvanometer will show 0 deflection. At that particular point there will be no current. So what is the potential difference across this length? That is across this length Cj. Let us assume that the L be the length of this segment alone, Cj alone. What is the potential difference? There will be a potential drop here, which is given as V is equal to I into R. Yes or no? What is potential difference formula according to Ohm's law? According to Ohm's law, we will write potential difference to be V is equal to I into R. Now let the length be L. Okay, so what is the potential difference across this length will give the value of EMF of the cell. Okay, that is the EMF of the cell. So I can write sigma psi is equal to, psi is the EMF, which is equal to I into RL. I will write RL is again resistance per unit length. So the potential difference across this Cj will give the value of the EMF of the cell, which is determined by the formula psi is equal to I into RL. So this EMF has a direct dependence on the balancing length, where psi proportional to L. I is constant, R is also constant. So this value of potential difference depends on the balancing length of the wire. Is it clear? Take your book, children, page number 113. Figure 2.27. Under that there is a paragraph which explains about this. Take that paragraph, children. The first and second paragraph talks about how the potentiometer is, and the second paragraph is the principle of the potentiometer. What is the principle of a potentiometer? When you maintain a steady current across the wire, there will be a zero deflection at a particular point on the wire where there is no current. The balancing length will give the value, the resistance across the potential drop across that Cj will give the value of the EMF of the cell. So that is the principle. Okay, now let us take that paragraph. Let contact be made at any point J on the wire by jockey. if the potential difference across Cj is equal to the EMF of the cell, that is potential difference, there will be definitely a potential difference that is created across this length. There will be a variation of current, but at a particular point the current will be zero. So what is the potential drop across this length will give the value of EMF of the cell. Okay, so there is no current flow through the galvanometer and it will show zero deflection. Cj is the balancing length. The potential difference across Cj is equal to IRL. That is what I have written here. So what is the potential difference across Cj? It is given as IRL, where I is the current flowing through the wire and R is the resistance per unit length of the wire. Hence, psi is equal to I into RL. Since I and R are constants, psi proportional to L, the EMF of the cell is directly proportional to the balancing length. So this is the equation I wrote. EMF is directly proportional to the balancing length, Okay, so this is about the first part of the potentiometer. The second diagram is comparison of EMF of two cells. Now here instead of one cell I have taken two cell. This may be a Leclanché cell or this may be a Daniell cell. Two primary cells are taken, and if we want to compare the EMF of these two cells, that can be done by potentiometer. Again the same circuit diagram, primary circuit is given. Now this is the primary circuit, children. Primary circuit, you have a battery and a key, and here is a rheostat. Now through this rheostat you can vary the value of current, rheostat or variable resistance. So this forms the primary circuit. Now battery positive terminal is connected to C and the negative terminal of the battery is connected through key, rheostat and to the other terminal D. So this forms the primary circuit, and here is the secondary circuit. Now you have what is called as a DP-DT switch. Now a DP-DT switch looks like this, children. It looks like a box. Now where you have 6 points like this, terminals like this. So here you have all the three. These three are considered to be positive. The other three is considered to be negative. So this 2 is connected to one cell, and here the two terminals are connected to the other cell, and there are two more points which is connected to the potentiometer circuit. So this switch is called as DP-DT switch. What is this switch called as, children? DP-DT, double pole double throw switch. Now there is a button here in the center. When I press the button to this side, this cell is included. When I press the button to this side, this cell is included. So you can include one cell at a time in the circuit using this double pole double throw switch. Now this is used because it involves two cells. So we go for this DP-DT switch. Okay ma? Right? So that if the switch is pressed on to this cell will be included in the circuit, and if the switch is pressed on to this psi 2 will be included in the circuit, and the center terminals are connected to C, and the other side is connected to jockey through a galvanometer and a high resistance. Okay, so this is how the connections are made in a potentiometer. Now what you do again? Now press the switch to this cell. So this is psi 1. Now this cell will be included in the circuit. After you include the cell in this circuit, you move the jockey. Start sliding the jockey over this wire. Again at a particular point you will have no current in the circuit. So the potential difference of that potential drop across that is taken as psi 1, which is equal to I into R into L1. So where L1 is the balancing length of the potentiometer wire with the first cell being connected. Now after finding out the balancing length for a particular value of current, now you move the, turn the switch to this second cell. Now this cell will be included in the circuit. Again, once again repeat the experiment by moving the jockey over the wire at a particular point. Again the galvanometer will show zero deflection. So the potential drop is given as psi2 equal to I into R into L2. Because it is the same wire, I remains the same, R remains the same. Balancing length alone will be varying because there are two different cells. So balancing length will be different. So this is the first part. Now second, what you do, again you will have to take the reading. So vary the current. Then include once again the first cell, take the balancing length. For the same value of current, include the second cell, find out the balancing length. Okay, so two sets of reading again is taken. Then again change the value of current, repeat the experiment for different values of current, and the average of that will give the value of the ratio of psi1 by psi2. So here I have psi1 equal to IRL1, psi2 equal to IRL2. So divide one by other, I have psi1 by psi2 equal to IRL1 by IRL2. So IR gets cancelled. So psi1 by psi2 equal to L1 by L2. So this is the formula to compare the EMF of two cells using potentiometer. So you can vary the current using this rheostat and find out balancing lengths for different values of current. So this is how a potentiometer is used to compare the EMF of the cell. Okay. The third use is how to determine the internal resistance of a cell. So the internal resistance of a cell can be determined using a potentiometer. Again, look at the diagram. The connections are the same. Primary circuit is the same. Battery to key to D terminal, and here is a cell whose internal resistance has to be determined. Now that is connected to C, and the negative terminal of the cell is connected to jockey through a galvanometer and a high resistance. And the extra thing that we do here is you connect a resistance, known resistance across this EMF, across this cell and a key. So this is the circuit which has to be added. Other things you are already familiar. So you have a known resistance box and a key included across the cell. Okay. So the other things are the same. So the connections are clear. Now how the experiment goes on. Now a resistance box and key K2 are connected across the cell with K2 open. So initially this circuit is open. With K2 open, the balancing point J is obtained. So with the K2 open, in the sense this resistance is not included in the circuit. That is what they are trying to mean. If K2 is closed, this resistance is included in the circuit. K2 open in the sense the resistance is not included. In the absence of the external resistance, find out the balancing length which will give the value of EMF of the cell. Yes or no? That is the first experiment we did. Now what is the first experiment? Now here there is no resistance box here. Now in the absence of a resistance box, when you move the jockey, now that potential drop will give the value of EMF of the cell. That is what we discussed earlier. Now the same thing is done for the first part of the experiment. With K2 open, find out the potential drop. So which is given as psi proportional to L1. You find the balancing length. Now what you have to do is, a suitable resistance is included in the resistance box. Now this is a known resistance box. You can fix a value of resistance in this resistance box. So fix a value for a resistance and close the key. So K2 is closed. Right? If K2 is closed, this resistance is included in the circuit. Now once again move the jockey. Now you will have current flowing through the cell, and the current value is given as, what is current formula? I is equal to V into R. Okay, so V is nothing but psi. Sorry, I is equal to V by R. So V is psi R is, I need to include the internal resistance of the cell and also the external resistance. So I have R plus R. So this is the value of I that is flowing across the wire. So current is I. What is the potential difference? Potential difference V is equal to I into R. Correct? Okay? Yes or no? So I is, what is I now? I is psi by R plus R into R. Okay, so this is the potential drop. Is it clear now? Once again go through. In the absence of an external resistor, the balancing length is psi proportional to L1. Then what is the current flowing through the circuit? I is equal to V by R. So I is equal to V, instead of V I have psi. So psi by the total resistance is the internal resistance plus the external resistance. So it is R plus R. So that is the value of current. So to find out the potential drop, V is equal to I into R. I is psi by R plus R into R. Okay, so this, now you move the jockey. So this is proportional to, so psi R by R plus R proportional to L2. Okay, so when you simplify these two equations, I will have a psi will get cancelled here. Now this equation, let me take this as equation 1, equation 2. Now simplify these two equations. So left side you have psi, that gets cancelled. So which term alone will be there? Here I will write, children. R plus R by R is equal to L1 by L2. Okay ma? Now simplify this. This I can write it as R by R plus R by R equal to L1 by L2. So this is 1. So you will have 1 plus R by R equal to L1 by L2, or R by R equal to, I have L1 by L2 minus 1. Okay, so I need to find out only the internal resistance. So take this R to the right side. So R into L1 by L2 minus 1. Again when I simplify, I have R into L1. Take this to the cross multiply it. So it is L2 divided by L2. So this is the formula to calculate the internal resistance of the cell using the potentiometer. Okay, so this derivation is there in your textbook 114 page number. Substituting the values of R, L1 and L2, the internal resistance of the cell is determined. The experiment can be repeated for different values of R. It is found that the internal resistance of the cell is not constant but increases with increase of external resistance connected across its terminals. So when you increase the value of the external resistance which is connected here, if increasing the value of external resistance will increase the internal resistance of the cell. So this is about potentiometer, children. Go to book back, children, book back question, page number 125 exam question number 11. Question number 11, it is based on today's topic. Potentiometer wire has a length of 4 meter and resistance of 20 ohm. It is connected in series with resistance of 2980 ohm and a cell of EMF 4 volt. Calculate the potential along the wire. So try that sum. I will also do it. You also try to get the answer. And one more sum based on this. Based on internal resistance, a cell supplies a current of 0.9 ampere through a 2 ohm resistor and a current of 0.3 ampere through a 7 ohm resistor. Calculate the internal resistance of the cell. So these two problems you try. I'll be doing this in the next class, but before that you also try based on the formula what I have done. Okay ma? So see you children with the next topic.